Hello and welcome to lecture number 14 in the Objective-C programming course. So this is almost the last lecture. The actual last lecture will be the next one, lecture 15, in which we are going to think and talk about what is ahead of us, what opportunities do you have knowing all the stuff that you learned in the previous few months, and also how to deploy your program to actually make it available for people, either just through internet or through things like App Store. In this lecture, we're going to quickly recap everything we learned, and we're going to prepare ourselves for the finals. So I didn't divide this one into modules because this is just a big recap. So just one module in this one. Okay, so finals are coming, and in case you didn't hear me last time in the class, the RCAD2, there's no midterm. So the marks for RK2 will be based on all the previous quizzes and projects 3 to 4. So basically everything you got your marks on after the last midterm is used to calculate your second part mark. The project 4 is due on December 11th. And again, this might be flexible in case the date we teachers have access to your marks. So if this date is postponed and we can make and change your marks, let's say on 15th, then this will be on 15th. But for now, think of 11th, and it will probably not change. So I have to put all the marks for all the projects and everything except for final exams until 11th. So finish your application, make it runnable. As I was explaining in the class, if something is there but doesn't work, that's a minus, and you'll get a minus on your mark. But if you feel that something is not quite working, if you feel that you're not able to finish it, hide it. Don't show it to me. Don't make me think it is there, so you won't get a minus. But don't make your application do nothing. That will, of course, get nothing. So the final exam will be quite easy. I'm saying that because it is easy. All the questions are multiple choice, so you just have to remember quizzes and the mock quiz, and just basically know and understand everything we're going to cover in this lecture, and just remember all the previous lectures. So let's start. First thing we started in the first lecture was the Hello World, the simplest application we created for OS X. There was a console-based application that was using just the text on the command line. And as you remember, Objective-C is a subset of C. So any C code works in there. Any C program will be compiled in Objective-C compiler. That means that first Hello World application was really looking like a simple C application. One of the differences was the import statement. Instead of use something that we used to, the include statement. And the difference is import is smarter. Import checks if the file is already included, and it's just more efficient overall. The function we used to put the text on the screen was nslog, and ns stands for next step, and next step is the legacy but still used wide in OS and Objective-C, in modern Objective-C used in OS development, OS X development, of course, the library that is coming from the next step operating system. So nslog was accepting the ns string, but it could actually accept something different. It could accept any class that would implement a certain method. So the main function was, again, really simple C-style function, the function that accepts some arguments, the number of arguments, and the array of arguments, and it returns some number. And basically 0 means the program successfully completed. So that that method that nslog expects and actually uses to print out any information from any class, or rather from any object of any class, is the description method. and that's the name of the method. And that method, of course, returns NSString, and this is what is going to be printed using NSLog. So if you created a class and you put this method inside your class, it will be called if you pass that class, or again, of course, if you pass the object of your class into NSLog as an object, and this string will be printed out. So the ID, you probably know it very well, it's a universal object holder, and this is just another kind of type which works for all the objects. So if you don't know what kind of objects you're going to deal with, use ID. And the common use of ID which we saw a lot is when we were overriding the init function, init method. It was returning an ID because, well, you never know what object are you working on. This is generic initialization, and the IB actions usually receive the sender ID. Again, the IB action can be changed, and at some point it say getting an action from a button, and next thing you know it's getting an action from a table. So ID works for a button, a table, or any other object. So it's a universal object holder. The class declaration is like so. You got an interface, then you got the class name and the parent class name. If you don't have a parent class name, you don't put a semicolon, you just leave the class name as it is. Then you might have member variable declarations in your class declaration, so in your class interface, but you don't have to. And if you don't have those curly brackets. In this example, we do have them. We have three: the integer, the NSString, and the ID. So every object in Objective-C is created on the heap. That means you always create pointers. There's only one way to get to your objects. It's using the pointer. So you will never see a use of an object without a star, because the only way to get to the object is using a pointer, which is denoted by a star. Next, after curly brackets, if you have them, you have method declarations, and minus stands for the instance method, the method that you call on the object, and the plus stands for the class method, and we call them static methods in some other languages. And the end of that declaration is @end symbol. So the methods, you know this very well, have a long name, and the arguments are usually put inside method, inside the method name, because the huge method name consists of different words, and those words usually correspond to different arguments. So the idea of having methods like this is describing them as human language, and also you can have nesting. So if you are asking for some method and that returns some object, you can call on that object as well, and you can nest multiple calls, or multiple messages. So that's that interface. Now, there's a lot of confusion between interface and Objective-C and interface in other object-oriented languages. It's not really the interface that we used to in Java. In Java, an interface is just a declaration of some class. It's a list of methods, basically. And you may implement it, you may not. You can have multiple classes implementing the same interface, and you think of an interface as that common language to talk between classes. And if multiple classes implement the same interface, that means they kind of are related. They can use some same data. They can work together at some task. Objective-C interface is not like that. Objective-C interface is just a declaration of a single class, and the only purpose of that interface is to define a class, and it's quite useless without a class. We have a thing in Objective-C that is like Java interfaces, and those are protocols, and we're going to get to them in a few minutes. So Objective-C interface looks like this. The only thing that is different from the implementation is, instead of actually implementing methods, all you have is the method name. And of course, you can put the arguments And like in any other programming languages, when you declare a method name, you may not even put the names of the arguments, because you can use different names in the actual implementation. So in this example, we have an interface with 3 different but quite simple methods: print set numerator and set denominator. This is our example of a fraction class. So the implementation looks kind of obvious, because you have the implementation instead of interface and then the name of the class, and this is the place where we put the simple variables inside the implementation rather than interface. And the format is the same. We put curly brackets and then the type of a variable and the name of a variable. And if we had an object here, we would put a class name, a star sign, and the name of the variable. The star sign could go either way. It could kind of touch the class name, or it could touch the variable name. It doesn't make any difference. And of course, in the implementation, you have the methods actually implemented. So we see those 3 but simple methods implemented in this section. And the implementation looks exactly the same as in C. You have the name of a method, and then curly brackets, the content, the actual code. And those methods are all void. They don't return anything. But in case we would have something that returns a variable, we would have a return statement in the end. Okay. So the objects usually created using standard alloc and init calls, and those alloc and init are not part of the language. Those are just methods in NSObject, and we inherit a lot of the stuff from NSObject. And most of the time you will work with some objects that, if not a direct child, but some indirect child of NSObject. So you usually have alloc and init available. Since this is such a common thing to do, to alloc a class and then get that new instance and initialize it, most of the classes that are built in and most of the classes that people write have a single replacement for that. And it's usually a name of the class without some additional stuff. Like in this case, we have an NSString, and NSString has a method called string, which actually does alloc and init in a single call. So you can use that. Some methods like NSNumber can hold different types. And when you initialize, you should specify a type you want to hold. And NSNumber could hold different types of numbers: floats, integers, doubles, etc. Because you initialize with this, instead of doing a simple init and then assigning a value, you can combine it into a single call: init with and then the type, in this case float, and you pass a number. And this single line would allocate a space for an object, initialize the object, assign it a value of 1, and of course the object will be holding a type float number. So this is not a part of the language in any way. This is a good design recommendation for you if you create your own classes, and usually you have to create your own classes. So when we were talking about property, I think both of us, or at least I did, have an older version of Xcode. And in that version, we were to create a property, and then we were to synthesize getters and setters, or in other words, mutators for that property. In this case, we would have a variable and then kind of automatic magic getter and setter generation. In the next version of Xcode, I think it was 4.4, but basically the latest is for sure having no synthesize requirement at all. So when you create a property today in the last version of Xcode and Objective-C, that's it, that's enough. Property will create a variable, getter, and a setter for you, unless you, of course, specify something different. But you don't need to use synthesize. Now, if you do use synthesize, it's not a problem. It just emits it. And your old code having synthesize, you don't have to delete it. It won't affect your compilation. Inheritance, again, you probably know everything you need to know. There's nothing to learn if you know inheritance from Java and C++, except for a single thing. Remember, there's no multiple inheritance in Objective-C. You can only inherit from a single class. And this is rather a good thing because you don't mess with multiple properties from different classes. They don't conflict, and you always get this simple, straight inheritance. Now, I said most of the classes you would work with inherit from NSObject, and that's true, but not much of them inherit from NSObject directly. So since there's no multiple inheritance, those inheritance lines are quite long because you can only inherit from a single class, but you still have to collect a lot of the data. Now, this flat inheritance structure in Objective-C and NS class of classes makes those trees really long, but you kind of see the idea, because if you take a look at, say, NS button, at NS view, and that goes, its immediate parent is something like NS window, and that has NS first responder as a parent, and in a few steps you get to NS object, and NS object probably doesn't inherit from anything. It has the most basic things you need. So sometimes when you create a class, you probably want to inherit from NS object, but you have to think maybe your class is connected to something more high level, something like a view. In this case, you would inherit from NS view, but you will still get all the good things you get from NS object. Okay, so exception handling, didn't touch that too much and didn't use it too much, but again, there's nothing new. It's the same as in Java. You get exceptions, you get try statement, the catch statement. You catch exceptions instead of failing your application. Okay, so in the second lecture, I think we created a simple web browser and we used the WebKit framework. Now we're going to talk about frameworks as we did in lecture 5, I think. But remember, when we created a web browser, we didn't really create a web browser. We just used the framework called WebKit that had all the classes and methods and documentation so that we can access a WebKit engine which would create HTTP requests, get some stuff from the internet for us, and render the HTML that our web server returned and showed it to us. Okay, so categories. You remember categories exist for two purposes. You could extend a class, or you can just divide the huge class into different parts so it's easier to manage. This is a simple syntax for a category. You create a category just like you create a class, but you have to specify the class name, the class you're creating a category for, and then the category name in brackets. And the implementation is the same. Now, this format allows you to have and to add stuff to a category completely outside the class. So you might be looking at the class, you don't see a method, you don't see an implementation for that method, but that method is there because somewhere later in the code you created a category for the same class. Now, this category is called a category because it has a name. And you always specify a name, because if you don't specify a name, that would be a nameless category, which is actually something different, and that's called class extension. Now, in a category, you can only define new methods. You cannot define new variables. So this is actually not extending a class as an entity, it's extending actions of the class. It's extending abilities of a class. If you want to actually extend a class, make it a different thing, you have to add new variables. And that is a class extension. It's just a category without a name. Now, because it's kind of a more powerful thing, you could still create new methods, but you can also create new variables. You specify the interface for that class extension just like you would do for a simple category, but you don't specify a name, of course, you just put empty brackets. The implementation of those methods and the use of those new variables should go inside your main implementation of your class. Okay, so if you have a category in a separate file, then you have to import the class definition first, because you have to know what class are you working with, what class are you extending. There's no limit on categories. You can create as many as you want. The only limit is the combination, the pair of class and the category should be unique. And that's kind of obvious. The same way as you don't have two classes of the same name, you don't have class plus category of the same name. Now, protocols, those are the things like Java interfaces, just a list of methods that don't really push you to do anything, just a list of methods. And if you were, as a class, to implement all of those methods, at least those methods that are required, those methods that make the protocol, you adopt a protocol. And if you adopt a protocol, that tells something about you. That tells you can handle certain number of methods. And if some other class adopts the same protocol, that means you and that other class has something in common. You and that other class can work on the same thing, can manage some communication between yourselves. So you kind of have some common language. And since you don't have multiple inheritance, there are a lot of cases where classes that don't have anything in common, don't have any relationship, need to have some relationship. They need to have some language to talk, and the protocols is the way to go. So this is a syntax for a protocol. If you don't specify the optional or required symbols inside the protocol definition, all of them considered to be optional. All of them considered to be required. And if you want to make some optional, you say optional, and then all the next ones until the end or until required statement will be optional. Now, in the interface, you specify the protocol name if you were to implement that protocol, if you were to adopt it. And again, you can put multiple protocols, and you just put protocols after a semicolon. Now remember, this is not inheritance. So it's not like in protocols you have multiple inheritance. You just saying, I will implement those methods in all of those protocols. You're not getting any new data. You're not getting anything. You're not inheriting anything. So it's not inheritance. And in the implementation, you have to implement all the methods that are required, but you also may implement those that are optional. Now, when you create categories, they are kind of semi-classes. They are sort of classes. So not surprisingly, you can also adopt a protocol if you are a category. So categories could adapt protocols the same way as classes do. They can adapt a single one, they can adapt multiple protocols, and if they implement all the methods that are required, then they are called adopting. Okay, so we briefly talk about WebKit, but the framework, or rather a framework, is an abstract term. It's just a collection of classes, methods, functions, and documentation logically grouped together to make development programs easier. It's just a kit to make your programming faster, simpler, because most of the tasks that you were to create, you were to have a common, and someone else did it already multiple times. So the best of those practices and solutions are put into a framework and made generic so that you can change them, modify upon your task and use. So the operating system Mac OS X has multiple layers, and each layer is represented as a framework we can use in Objective-C and Xcode. So the two layers we work most of the time are the lowest level, the foundation. Now the lowest, of course, without touching the core operating system and the kernel of the operating system. This is not the purpose of this course, but the foundation is the framework that deals with numbers, with simple operations, with stuff like dates, simple 2D structures like points, rectangles, squares, etc. And then we are working most of the time in this course with Cocoa. And Cocoa is the layer that works with all those visual elements on your screen, like windows, buttons, sliders, text fields, labels, etc. So basically everything you see on my screen right now is somehow from Cocoa. Now, this is a simple standard layering of an operating system. You start with some fundamental logical operations on your CPU and you end up with really, really high level stuff like a button or a sound or a file. This layering is really good, but all of the layers on top require all the layers at the bottom to be present and to be correctly working. That means the Cocoa cannot work without Foundation or without OpenGL, without core data, without animation, without core graphics. The Cocoa is the most dependent one because it's such a rich and powerful framework. It needs a lot of the stuff to be in place and to be working. Okay, so let's talk about a few data types we didn't talk about in the first few lectures. Arrays and dictionaries and sets, and the corresponding types in Objective-C, or rather in next step that we use are NS array and NS mutable array, NS dictionary and NS mutable dictionary, and NS set, NS mutable set. Now, most of the time you work with something that you want to change. So if you have an array, you probably want to add and delete stuff. But surprisingly, a lot of the time you don't need to add or delete stuff. You want to put something into an array and maybe pass it. And that's the only reason you want to put it inside an array. You don't want to modify it after. So you can use NS mutable array or NS mutable dictionary. So basically mutable type of any data type anywhere, and you won't have any problems. But you kind of losing power. You're losing the space. You have to think sometimes you don't really need the array or any data type to be data structure to be mutable, to be modifiable. Many times you want to, let's say, save a file, and all you want to say is those are the data types, the file types that I allow. And you have to specify those types inside an array. And you create an array for a single purpose, for just 1/100th of a second, to say to your operating system, these are the file types I want to allow. And if you make it a constant array, that would be faster, and you would save time, and you would save power of your computer, and you would save computation. Yeah, if you don't have a mutable data structure, then the only time you can put stuff inside is upon initialization. So when you create your array, you can initialize it with an object or objects and pass any number of objects, but after that you cannot change, you cannot modify, delete, or add stuff to the array or dictionary or a set. Now a dictionary is a data type that deals with, instead of indices and values like in arrays, it deals with keys and values. And keys could be any objects. Keys actually could be NS strings, and values could be any objects. And dictionaries are used widely in the system. And again, there are a lot of cases when you create a dictionary just to use it once to pass to some message. Dictionary are used widely in key value observing, key value coding, observing in general, core data, stuff like that. And sets, they follow the same pattern, but you don't have neither an index nor a key, you just have values. And of course, in a dictionary, you can have the same object in different keys, and in an array, you can have the same object in different places, in different indices. In the set, you cannot have the same object twice, because the only way that matters in a set is the object itself, and it should be unique. Okay, so remember the design pattern that Apple wants us to use, the MVC, the Model View Controller. The model is all the knowledge, all the data of your application, and we sometimes call it business logic. It most of the time has nothing to do with business as we think of it, as, you know, making money. Business just comes from busy. That means the busyness of your application, something that works inside your application, the model. The view is something that user sees and interacts with. So it's not just the data that you display on a user, like on a screen or with a sound or maybe printing on a printer. It's also the interface the user uses. So the buttons, maybe the touch screen, something like this. The user interaction agent is the view. And the controller is the medium, is something in between the model and the view. It gets the user actions from the view. It probably does something based on those actions to the model, or just asks the model to get some information. The model notifies the controller with this new information, and the controller updates the view so that the user can see what happened and what actions of the user led to what updates in the view. Other design solutions that are really widely used in the whole OS X thing is delegation. Now, delegation is exactly what it says. It's delegating the action of some object to another object. An object called the delegate acts on behalf of and at the request of another object. And delegation is a means for injecting application-specific behavior into the workings of a framework class without having to subclass that class. Now, as I said, the framework is usually really generic because they have to be generic. This is what makes them a framework. They have to be universal so that many different tasks could be done, could be solved with the same code. Now, when you have a task, it's not generic. It's super narrow. It's fundamental, and you have to kind of adapt the framework code for your task. Now, you can subclass that framework and just make not a framework, but based on a framework, something for your task. But subclassing is a lot of the time, and most of the time you want to just change maybe behavior of one single method. Now, this is where delegation comes in hand. You want to have a delegate instead of a subclass, and that single method, so you don't have to change the whole class, you just have to implement a method differently. And instead of calling a generic method or a method that even doesn't exist in a framework, you would get a call to method you provided. So an example of a delegate we used is, the first time we used it at least, is when we created a speech synthesizer and we wanted the speech synthesizer to clear the text field when it stops speaking, when it comes to an end. Now, we couldn't ask it when it was about to end because that would make a lot of the calls. But what we could do is, now the speech synthesizer itself knows when it's done. It has a method that is called when it's done. But we wanted to clear the text field which is inside our application, which is not inside the speech synthesizer. It's outside the speech synthesizer as an entity. So what we did is we made our application the delegate of the speech synthesizer. And we made our method, the method that we created inside our application, to be called when speech synthesizer is done, instead of a method inside the speech synthesizer. So that action of calling a method inside the speech synthesizer is now moved or delegated into our application. And the speech synthesizer is calling that method itself, but that method is in our application, and we can do anything inside our application. And what we did is we cleared the text field. So we didn't break any security bridge, we just made it so that one time, instead of calling the speech synthesizer method, the application method was called. Okay, so in the next lecture after that, we added more voices to our speech synthesizer. And we kind of did the same. We created a helper object called data source, and we said that the table view would have a data source, and the data source would be our application. Now, we kind of took some responsibility, and we said, okay, I am an application, will be your data source, talking to an NSTable view, of course. But if I want to be your data source, I have to play by your rules. And the rules are, you have to implement those two methods. Those two methods are used to populate the table view. So one of the methods is returning a number of rows in a table view. Now, when table view is created, it is calling its data source, and it's saying, well, how many number of rows do I need? The data source should know it, because the number of rows depends on what data is to be shown. Now, we created this method, and we just returned the number of elements in an array, because we use that array of voices from NS speech synthesizer as the data source. Now, the second method data source needs to have is a method that returns an element of each cell in your table view. Now, the table view is a table. It has a column and a row. So this generic method asks for some view by a row and by a column. So you have to return something different for every cell. So we just used that. We only had one column, so we used the row number as the index for an array of voices, and we were just returning different voices. So these two methods made it possible so that we use an array as a data source of an NSTable view by our application. So our application was kind of an agent between the actual data in array and the view in an NSTable view. Okay, so the two main things we connect the interface with the code with is the outlet and an action. An outlet is just like a pointer. It's a pointer that points to some interface builder element. And IB stands for interface builder. So for any element you want to access via the code, you have to create an outlet and connect it using Xcode. So in that random generator we created in one of the lectures, we had two IB outlets, one for the text field and one for the generate button. And if there's an action you want to call in the code by some action of the user or a machine, but from the interface builder, you create an IB action. And IB action is like the inverse of IB outlet. But if you want to access something from the code, you need to create IB outlet. So if you want to do something when the button is pressed, you create an IB action. But if you want to do something to that button, you have to create an outlet for that button. And it's totally fine if a single object has both action and the outlet. Okay, so another thing, another design solution that is widely used is a notification center. It's a subsystem of the foundation framework that broadcasts a message called a notification to all objects in your application that are registered observers of that event. Now, actual notification center can have different types. It can be of different type. And some notification center work only within an application. Some of them work within a process, and inside the process you can have multiple threads with multiple applications. And some notification center works within different systems, so you can have multiple applications sharing the same notification center. Now, we're not talking about this in this course at all, but we're talking about notification center within a single app when we were to implement a document-based application. Okay, so NS notification is the class that is used to pack a notification, and you can get the name of that notification and an object. So this center called NS notification center is doing registration of observer objects. It's transferring those notifications, so you can post a notification to that center and it will be broadcasted to all the observers, and you can unregister those observers that you don't want to get notifications to anymore. Okay, so those are some notification center methods. most of the time you work with the same single shared NS notification instance, and to get it you use that default center class method. And I know it's a class method because I see a plus here. And the second most common thing you do is you're adding an observer to the notification center. And the method is quite obvious. It says add observer, and then you pass an ID, the pointer, to the observer. Then the selector. Now this is the method that you want to react to. This is the selector that you want to get notifications when it fires. Then you get the notification name and an object. Now when notification of the name, this notification name containing the object, an object is posted to that notification center using post, this observer gets this selector. Okay, it also gets the actual notification. It gets this NS notification object, and you can get different information from that because you can post different information in that notification. So it kind of works like this. You have this notification center, and it keeps the track of the pool of observers. And in this case, we have two objects that are already registered observers, and another object is saying, well, notification center add observer me, meaning self, if I'm calling from within this object. And the selector, I want to handle this. And the name, some notification name and object, this doesn't matter. So if it's nil, then any objects will do. So after this is executed, I now am, as the object C, a observer of notification, some notification name. Okay, so the last but probably the most important design decision is the key value observing and key value coding. Key value observing and key value coding allows an object, allows you to access a property of an object using its name as a key, and observing allows an object to observe a property of another object. So you can use this to observe the change of some variable. So the mechanism that we used called binding, where we bound a value of some variable to a value of something in our interface, is using that key value observing. So binding is actually just a fancy name for key value coding and observing, and we can do the same thing without calling binding at all. Okay, so in one of the lectures we created our first document-based application, and what we did is we created an application, we created a model for a person, which was just a person class, and that class had a name and a race. We created multiple persons, put them inside an array, and we used that array as a source for NS array controller. So we created this MVC structure where we had the model outside, we had the controller, which was actually our application with NS array controller, and we had the view, which was our nib file or zip file without compiling the user interface. Now, those things connected to the controller from the view, like the button and the NS view, had most of the time had the NS array controller as a target. So we were asking NS array controller to do something with our array, like add a new person or delete some person. We never actually called the NS mutable array itself. We just created it and we used it as a source for NS array controller. But NS array controller can do anything we want with the array, so we didn't really touch an array. We didn't need to, because NS array controller is a secure way to deal with it. Okay, so in the later lectures we started doing undo, and the idea of having an NSUndo Manager is it can manage the undo redo stacks, and all we have to do is provide it with the reverse or inverse method to keep undo redo sane. And you probably remember that stack thingy. You have an undo stack and a redo stack, and when you, in this example, created 3 actions, the inverses of those actions are placed inside an undo stack. And if you do undo, the top one is being pushed outside into the redo stack, and you can go on, do redo, undo, redo, undo. The movement between the stacks makes the message invert. So you need to put the inverse of a message inside a different stack. And the way you put a message is you use NSInvocation. So you can pack a message with a selector and all the arguments and the object, like the source of that message, inside an object called NSInvocation object. So here's an example. You have a method called make it hotter that makes the temperature go up 10 degrees, and you can make your undo manager prepare the inverse of that action. So to prepare the redo or undo to make it colder, and all you have to do is to put both prepare with invocation in both methods, and now they're completely compatible with NSUndo Manager. Okay, so observers, again, these are the things when you have key value observing, you can observe some key path, and the key path is just a path to some key. You can have a name dot something, and when you add an observer, you can observe value for some key path, and here's an example when we use NS dictionary that is actually a constant dictionary. You get the change inside the dictionary. Okay, one of the last things is archiving, and this is just a more fancy name than serialization in Java, just representing objects as a stream of bytes so that you can put them inside a file, and then you can unarchive them and get your object back into an application. So we used NSCoding, and this is really simple because we again used something that were provided for us, and we implemented some of those methods to do saving and some of those methods to do loading, and we basically created an NS data object which is just a stream of bytes, and we wrote that stream of bytes onto the file system, and later when we wanted to load it, we were to read the stream of bytes and encode back from NS data into the object. So this is how we did it, and I'm actually gonna skip this because we are almost out of time. So the idea of encoding there was that you encode only your immediate children, and if your children are something complicated like an array or an object, they will handle the encoding of their immediate children. So you get this chain of encoding. You only think about your bottom layer, and anything deeper is the responsibility of that bottom layer. So remember the structure of OS X application. It's usually a single package with all the files inside the package, and when you just double click or run that package, the executable is being run, but all the resources, everything could be inside. Okay, so the core data is the thing that we use only once, but I think many of you used in your application because it's a really simple way to work with entities to objects without really thinking about objects as programming language objects. It's a really high level programming, thinking of data and instances of the data. Okay, so I'm actually gonna stop here. We're out of time, and you can check there are a few slides left, but we got those slides from all the previous lectures. So I wish you good luck on the final. Again, if you just stick with this and remember everything, I think it will be quite simple. And see you in the next lecture, which will be the last one. See ya.